We're Ben and Christine, and we're talking about math. This is the AP Calculus AB and BC FRQ from 2014. We have question 1. The question says, grass clippings are placed in the bin where they decompose. For t is greater than or equal to 0, but less than or equal to 30. The amount of grass clippings remaining in the bin is modeled by A of t equals 6.687 times 0.931 to the t, where A of t is measured in pounds and t is measured in days. So part A asks, find the average rate of change of A of t over the interval 0 to 30. It wants you to find the average rate of change over 0 to 30, and so what we're going to do is we're going to use the slope of the secant. So we're going to get A of 30 minus A of 0 over 30 minus 0, and then so that equals 6.687 times 0.931 to the 30 minus 6.687 times 0.931 to the 0 over 30 minus 0, which equals 30. And so you plug that in to your calculator, and you get that the average rate of change is negative 0.197 or negative 0.196 pounds per day. And so this part of the problem is worth 1 point, and you get that from the correct answer with units. Part B asks us to find the value of A prime of 15 using correct units, interpret the meaning of the value in the context of the box. So using the exponential derivative of A of t, we're going to get that it equals 6.687 times 0.931 to the t times the natural log of 0.931, and that equals 0.478094 times 0.931 to the t. And so A prime of 15 is, we're just going to plug 15 into here, and so that is 0.478094 times 0.931 to the 15, and you solve that, you get negative 0.164 pounds per day of grass, and that's 1 point for having the correct value for A prime of 15. So the interpretation is this value represents the rate at which the amount of grass changes on day 15. You get 1 point for the interpretation, and so this part of the FRQ is worth 2 points too. C asks us to find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the time interval from 0 to 30 days. 1/30 times the integral from 0 to 30 of A of t dt, and that equals A of t. In this situation, we're trying to find t in the normal function where that would exist. So we solve the integral, we get 2.75264 equals A of t. To solve for an integral, a TI-84, you'll go to the math button, press that, and then you can scroll down, you'll see that's number 9. You can either just press 9 or just press enter on 9, and then you fill it out that way. And that equals 6.687 times 0.93 to the t, because that was a given in the original context of the question. So we divide 6.687 from both sides, we get 0.41164 equals 0.931 to the t, and then we can get t by using logarithms. So log of 0.41164 divided by log of 0.931 equals 12.415, and so this problem is worth 2 points. You get 1 point for the integral right here, and then 1 point for the final answer. So part D says that for t is greater than 30, L of t, the linear approximation to A at t equals 30 is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time which there will be at 0.5 pound of grass clippings remaining in the bin. Show the work that leads to your answer. And so we know the linear approximation formula, so L of t is going to equal f of a plus f prime of a times t minus a, and t is going to be the time that we're looking for. So at a equals 30, L of t equals half a pound, and t represents days. So L of t equals a of a, which equals 30, plus a prime of a times t minus a. So L of t equals a of 30 plus a prime of 30 times t minus 30. And so you get 2 points for that expression right there, so that's important. And then we get a of 30 equals 6.687 times 0.31 to the 30, which equals 0.782928, and so that's just plugging 30 into the original given equation. A prime of 30 equals negative 0.478094 times 0.93 to the 30, which equals negative 0.055976, and we know from part B that A prime of t equals 0.478094 times 0.93 to the t, and so we're going to try to solve for t from there, because we know L of t equals 0.782928 plus negative 0.055976 times t to the negative 3. So we're going to set L of t to 0.5, and t minus 3, we can multiply this through, and that's distributive property. And then, so by setting L of t to 0.5, we get 2.4622 minus 0.055976 times t. So we're going to try to solve for t from there. So we get negative 1.9622 equals negative 0.055976 t, and then we get t equals 35.054 days, and that's +1 for the answer, +1 for having L of t setting that equal to half a pound, and then +2 for this expression right here.
The first multiple choice question we have is multiple choice 1, question 13. The question is, let f be a function defined for all real numbers x. If f prime of x equals absolute value of 4 minus x squared over x minus 2, then f is decreasing on the interval, and then it gives us a bunch of different options. In order to figure out where f is decreasing, we must first find the critical numbers of f prime of x. Before we can do that, we have to split up this absolute value so that we can find the critical numbers. To split up the absolute value, there's a variety of methods we can do, but the easiest and most straightforward is by drawing a graph and seeing where that graph needs to be changed in order to reflect the absolute value. In this graph, we can see that from negative infinity to negative 2, the graph would be negative, but that can't happen because this is an absolute value problem. This also occurs where x is greater than 2. We must add a negative sign so that the equation accurately reflects where the answer is going to be positive. Now that we have split up the absolute value, we can rewrite f prime of x as negative 4 minus x squared over x minus 2 for x is less than negative 2, 4 minus x squared over x minus 2 for negative 2 is less than or equal to x less than or equal to 2, and negative 4 minus x squared over x minus 2 for x is greater than 2. To find where x is decreasing, we must find the zeros and critical numbers of f prime of x. Looking at the equation of f of x, we see that it is undefined at x equals 2 because the denominator is equal to 0. By factoring the top, we can see that x equals plus and minus 2 are also zeros. Therefore, there are critical numbers at x equals plus or minus 2. Now, we will set up intervals to test where f prime of x is negative or positive. We're going to set up a table that has sections for intervals, test values, plugging in the numbers, and determining whether it is negative or positive, increasing or decreasing. Our first interval is negative infinity to negative 2. Our test value is going to be negative 3, and when we plug that in, our answer is negative 1, which is negative, so f prime of x is decreasing. The next interval is negative 2 to 2, and our test value is 0. Plugging this in, we get negative 2 as our answer, so f prime of x is decreasing on this interval as well. Our final interval is 2 to infinity, and our test value is 3. When we plug this in, we get 5, which is positive, so f prime of x is increasing. So this shows us that f prime of x is less than 0 on the interval negative infinity to negative 2 union with negative 2 to positive 2, which can be rewritten as negative infinity to 2. So therefore, f of x is decreasing on negative infinity to 2. The next multiple choice question is number 14. Let f be a differentiable function such that f of 3 equals 2 and f prime of 3 equals 5. If the tangent line to the graph of f at x equals 3 is used to find an approximation to a 0 of f, that approximation is, and then we're given a bunch of options. So once we see that this is an approximation, we need to remember the formula for approximation using tangent lines, which is f of x equals f of a plus f prime of a times x minus a. And we are given in this problem that f of 3 equals 2 and f prime of 3 equals 5. So we know that we're going to be using 3 as a. And we want to find an approximation of a 0 using a tangent line at x equals 3. So a equals 3. So here's the formula again. And then we're going to plug in the information that we have and what we want to find. So here we have 0 because we're trying to find where x equals 0. 2, we get that from f of 3 equals 2 plus 5, which is f prime of 3 equals 5 times x minus 3. And then if we solve this formula, just distribute 5 through the equation, we'll get 2 plus 5x minus 15. Simplify this, add 2 and negative 15, and get negative 13 plus 5x. Add 13 to both sides and get 13 equals 5x. Divide both sides by 5, and we get x equals 13 over 5, or 2.6. And this is answer option C. Our final question is number 15. For this question, we are given a graph that shows a line sloping upward with a concave upward towards point A, where there's a discontinuity. and then going up, hitting a maximum at somewhere between A and B, and sloping downwards again towards B, where there's another discontinuity. And this time the line jumps from having a y value of 2 to a y value of 1. The question asks us to see which of the following statements about f is true. In order to do this, we're just going to look individually at each of the statements and see which ones are true and which ones are false. Before doing this, we're going to review a couple things that are important to remember when looking at graphs. So the limit as x goes to b of f of x does not exist because the limit as x approaches b from the negative side is 2, while the limit as x approaches b from the positive side is 1. Then the conditions for continuity on a graph are the limit as x goes to n of f of x exists, f of a number n is defined, and the limit as x goes to n equals f of n. Keeping those in mind, we start looking at the answer options. For A, it says the limit as x goes to A of f of x equals the limit as x goes to B. We see that this is not true because the limit as x goes to B is not defined, whereas as the limit goes to A, it is defined. So we can say A is not true. The second thing, limit as x approaches A of f of x equals 2. Although there is a discontinuity, the limit as x approaches A from the negative side and the positive side is the same. So this one checks out. Part C says the limit as x goes to b of f of x equals 2, but that's not true because the limit as x goes to b is not defined. The next one says limit as x goes to b is 1. That's also not true because it's undefined, so there is no limit as f of x goes to b. The final thing, the limit as x goes to a of f of x does not exist. Well, at first might seem like a good option. This is not true because as shown here with for a limit to exist, the limit as x approaches a from the negative and positive side is equal, therefore the limit exists and this is not true. So we can select answer option